Hello? Hello. Welcome back from lunch. Thank you for joining me. My name is Heather Downing. I'm from the USA, specifically right in the very middle, Kansas City, Missouri. I'm very excited to be here and present this talk to you. I come from a developer background primarily, and 4 years ago, I joined a security company. So this talk is all about what I learned I wish I had done in the beginning. But that was a very long title, you know? And I feel like maybe Defensive Coding Bootcamp was a little better. So the point of this talk is to get helpful tips on how to incrementally be a little bit more secure as just a regular developer, some scenarios to avoid, right? And some useful non-language specific knowledge. And of course, just a quick starting point. This is meant for you to refer to later every time you get a project started. So let's start with the first lesson I learned, that my perception shifts with the experience and time I'm exposed to security. The further I go along the path, the further into discouraging and realistic I fall. You know, we start out not knowing anything about how to code securely, and then you learn one thing, like slap a login right in front of your app, and you feel pretty good about that. I feel pretty confident, yeah? And then you get hacked. And then that's a little bit discouraging, no? So don't worry. I'm already clearly at the second bottom here and on my way towards mastery, and that takes a little bit longer. Be aware that in security, there's often a helplessness that can hit even the more experienced folk. The realm of possible attacks is always shifting. The first thing I discovered when I started going down this rabbit hole is that you shouldn't always build things yourself. As a developer, I love building everything myself because I have control. But I don't know what hackers are going to do unless I decide to study that. And until I came to a security company, I didn't have time to do that. I was too busy building, right? I used to write a lot of manual processes, but the more of those you write, the more bugs you have and the more security holes you also have. So coding at a framework level is going to yield a lot more secure results than rewriting some low-level module. Here's something that I wish I knew ahead of time. It's not if, it's when somebody is going to take a vital piece of information and exploit it. With any sort of shared credentials, you should understand that they can leak and be prepared with a process in place right from the very beginning, meaning your keys. Look at how fragile all of these systems are. Has anybody heard of the Code Cove breach? No? Excellent. Let me tell you all about it. The breach was done by very sophisticated attackers at the time who exploited a mistake in how Code Cove built Docker images. They used this to modify the script, which allowed them to send the environment variables from the CI of Code Cove customers to a remote server. That's unfortunate, isn't it? If you're interested in the details about that, grab this URL. It's pretty fascinating. So you see, you need to make sure that you don't hard code your keys anywhere in your application. The difficult thing about this is that according to GitHub, who has literally millions of repositories, the whole reason that they started automating sending you emails that aspects of your code was insecure is because of the sheer amount of us who are lazy and check in hard-coded keys. So keep in mind, if you do a private repository system that does not use GitHub, that might not be something that you'd be flagged with. Also, be skeptical about the new thing on the block. This is hard for me because I love all the edge technology. I get bored very easily, so I'm always interested in the next thing. But using new or immature libraries can yield poor results. You don't know who wrote the code, especially if it's open source. And if you can't trust that code on some level, you probably shouldn't include it in your project. I mean, popularity doesn't always mean quality. It might just be old or be there for a while. Is there more than one committer? Are other popular frameworks even using this library? Has it been backed by a foundation in the event that the maintainer gets hit by a bus and no longer can maintain it? These are good questions to ask anytime you include a library. This is my favorite slide of the deck. While it's true you won't always know what you don't know, the majority of top 10 security issues developers face hasn't changed much since 2017. That means you can familiarize yourself with what they are and curb probably about 80% of the issues. The biggest concern that I have here is that SQL injection only went from the first place to the third place. That's still happening now, not because of the security experts in our field, but because of developers like you and me. Because we don't know what we don't know about the scenarios. So because of that, we need to challenge what architectural decisions have been made even before you arrive at a company with an already created code base. This is really tricky, especially if culturally you're not used to challenging any sort of authority. I was definitely raised to be somebody who respects authority and never questions it. But I'd like to invite you to change the way you view it. You are at the mercy of the architectural decisions of the places that you worked for the first parts of your career. And you don't challenge that, but over time, you need to start raising your hand. And I would argue one of the fastest ways, if you were in my team, to gain trust rapidly is to just raise your hand and say, oh, by the way, have we checked to see if we're rotating our keys or if we have automation in place for that? I bet you they probably didn't think about it, and now you look like a genius. You're welcome. Something to keep in mind is as we talk about the different stacks that we identify strongly with, like I am a .NET developer, I am a Java developer, we get very tied to the stacks. But sometimes they can kind of blur what's really happening just at an overall computer level. Don't be afraid to challenge the assumptions of these stacks that you've learned. It's very likely that the things you've learned are only one possible way of doing things and not necessarily the best, especially if the framework you're in gives you a lovely Hello World sample right at the beginning of their docs and one specific way to do it. Particular frameworks have opinionated approaches. That doesn't mean that it's not possible or preferable to do it in a more secure way. It's better to understand how your framework fits into the bigger world of code. Some of the frameworks go too far into covering up what is happening and obfuscating that flow. So you end up completely trusting your framework approaches, and you often don't have the ability to audit the security of it. The next thing that I learned is know which of your tests actually cover security scenarios. I did not always know that. Sometimes they were mixed in with login actions, which may or may not include just UI-based things. At this point, I would suggest you literally name them security tests within your application framework so that it's easier to pinpoint what you have covered and what you have not. That way you don't have to traverse all over your testing framework trying to discover which holes are filled. A lot of places have no tests. I am actually not a testing fan. I did it reluctantly. I just wanted to build the thing. I wasn't interested in a TDD approach, and I was very wrong about that. But I think differently now. It's so tough to know if a vulnerability can get through if you're not set up for tests in the first place. So reluctantly, I would advise, please make sure you at least have some tests that cover security. I also discovered that securing your app does not mean that your data is secure. I never locked my stuff down ever, so that a user could only see their data in an API call, and not anyone's data. All it takes is just changing a couple of numbers, and suddenly I can see my friend Jennifer's data. And that sounds so terrible and lazy, but the framework wasn't set up to be secure in the first place at the time. So I just trusted it, and it turns out that I got pulled into a security audit about how come I can just change this number here and get a different user. That's so interesting, Heather. I just was never taught when I went through Bootcamp anything about how to code securely, just to code what's possible. That's kind of terrifying to me. I didn't want to become a paranoid developer. I wanted to learn at least some basics. Securing your app is one thing, but securing your data is a whole other thing. Frameworks usually give you some of that stuff for free, but you generally have to write some custom code to secure your data. Don't assume that popular tech is secure by default. Do you know that Kubernetes secrets aren't really secrets? They are base64 encoded strings. All I'm saying is, look into the tech behind the name so you understand what you're really working with and not just blindly trust it. Which brings me to something I learned at the current company I'm at. There's more than one way to approach authentication. It's all incredibly confusing right away, and the different ways to approach it and understand those flows is so critical for beginners. Not just OAuth, but SAML, WebAuthn, Basic Auth, and there's much more that's coming. FYI, don't use SAML if you don't have to, but if you have to, I feel for you. There is more than one way, and in fact, the auth world is changing probably one of the most rapidly I've ever seen. Now there's more and more layers of security protocols that you can put on top that actually are not difficult for you as a developer. OAuth 2.1 is coming out. I'm very excited about that. And just keep in mind that this is something you're going to have to stay a little bit on top of. You don't need to read the news every day about it, but just be made aware, check maybe once a year to see where things are and if you need to adjust your existing project accordingly. I also discovered that doing encoding and serializations properly were an issue. You know, the term encode has been used in the past to denote encryption and may still carry that meaning outside of a technical context. In the software world, it's only meant as a data handling mechanism that never provides any measure of security. Did you know that? While encryption is meant to guarantee data confidentiality, some modern encryption algorithms employ additional strategies to guarantee data integrity, sometimes by means of embedded hashing algorithms, as well as authenticity. And of course, there is encoding. I pulled this from the OAuth site because I thought it was hilarious. They go over different scenarios that are fairly common to us developers, and I thought I would share the common solution that came up on most discussions. Here's another scenario. I'll read this one. A React application calls a set of Spring Boot microservices. Being the functional programmers they are, they try to ensure that their code is immutable. The solution they came up with is serializing user state and passing it back and forth with each request. An attacker notices the R00 Java object signature and uses the Java serial killer tool to gain remote code execution on the application server. There's ones about PHP too. This one gets me because I've actually done it, but in .NET. I definitely passed along some information inside that probably should not have, like the level of access that my user has. And it turns out that what I was reading was not the actual user object. I was only reading what level of access they had in order to show them that screen. Again, I'm just speaking from the pain of my experiences so that you don't have to feel this pain. OWASP notes the best way to prevent insecure deserialization attacks is to never accept serialized objects from untrusted users. I'm going to let that sit with you for a second. Are you doing that? Bet you are. Alternatively, of course, you can use serialization tools that allow only primitive data types, or use deserialization methods like JSON, XML, and YAML that are language agnostic. Please don't use insufficient hashes. I've done this as well. Do you know many cryptographic algorithms and protocols should not be used because they have been shown to have significant weaknesses, have been broken, solved, and of course, most computers now are much faster than they used to be and can solve things automatically for the hacker. Would you like me to show you a couple of deprecated ones just to check the box? How about this one? That, or that? Look familiar to anyone? Just because it's available does not mean that it's safe to use. In my case, We have every single algorithm, I feel, in the .NET library. We've never taken them out. So just because you can hit a dot in your autocomplete, it may give you the wrong hash. It's not wrong 10 years ago, but it's wrong in 2022. Just because something is available in a framework doesn't mean it's secure to use at this point in time. Something about log4j. Security is ever shifting and changing, so it's exhausting and endless. So how do you know if the thing you wrote last year is still secure? But you didn't think about it, especially if you've moved on from that company. There's an initiative called NIST, and they're really good for this. They write standards every year based on current shifts in the market. PCI compliance is an example of a good one to use for leverage with your company and management team to be proactive instead of reactive to vulnerabilities. You have to actively use industry's current standards to back up the need to attend to and maintain your application. Like our keynote said, to keep those lights on includes keep the door locked. The decision to execute is not always in your hands and usually never in our hands because we are the builders, right? So don't take it too much to heart if they say no. It's a company risk decision and you should word it just like this. Oh, okay, this is what I would do based on what the current industry standard is to prevent company risk. I'm sure they would like to not have the lawyers hear that statement, right? So that's a good way to get a little bit more time and resources to continue to maintain your applications. Your job is to explain the risks and bring the evidence. If you're interested in how to start with this, NIST/Cyber Framework is actually globally a volunteer base that's meant to be from the builder to the C-level person, to the decision maker. It's guidance based on existing standards and practices so that organizations can better manage and reduce cybersecurity risk. It's designed to foster communication a little bit better amongst both internal and external organizational stakeholders. So it's adopted worldwide and volunteer-driven. Lots of good FAQs and guidance for small businesses on things to keep in mind. Validate everything every time sounds so tedious to me. Don't ever believe what's coming into your system. I'm sure you've heard that before, but in practice it's difficult to do because you are in the middle of a wonderful flow, trying to hit that wonderful business use case, and you have to stop what you're doing to consider which trust boundary you're crossing. Always validate, even if it's an internal API inside of your company that another team works on. When data flows across a trust boundary from outside your system, and when I mean your system, I don't mean your company's system, I mean the system that your application is responsible for, okay? You shouldn't trust it. Do you trust that your database hasn't been breached? I could not believe when this happened to me. There was a data replacement breach that ended up happening to me about 7 years ago. It wasn't me personally, but I was on that team. And we just served up to our browser some data that was put inside of our database, and they replaced it with some JavaScript that, of course, was a keystroke tracker for everything else that the user was doing. You know what would have helped? If I validated that what I was retrieving was just an email address and not a script. This is a simple thing here. Again, I'm not asking you to become a security expert. Just put a safeguard in place. Are you getting expected data? Is the timestamp of the data too old, too far in the future? These are things to just bring up and discuss architecturally with the rest of your team. How can you get string comparisons wrong ever, right? Surely this never happens. A lot can depend on character encoding and regex missing some of the malicious strings that come in. Because don't assume that a user is going to follow your use case. I say this usually in annoyance to the users who can't follow simple instructions and get confused. But this also applies to hackers. There are cheat sheets out there that inform a hacker how to input SQL injection. They don't even have to be good at it. So try to account for all the possible edge cases you can. When I say all, meaning the obvious edge cases to not isolate a real user from what they're trying to do, but enough to protect you from some of this. The good news is, and yes, there is good news in this presentation, you can be lazy and secure. Just start with that input validation. Only allow letters in the username field. There are shortcuts. You don't have to hand code all the things. Using a vetted third-party authentication option removes a lot of risk from your shoulders, but of course, I'm biased a little bit because I work for an authentication company. But I did notice a difference tremendously. On the other hand, there is quite a bit we all have in common. Although a specific industry may think they're more unique than they really are, I'll give you an example. Most automotive companies feel their industry is in a silo. They feel their requirements are specific just to their industry. And if a vulnerability is not labeled as automotive specific, they don't feel they need to pay attention to it. I don't know about you, but I have a vehicle that definitely has a computer in it. So about 80% of security is a common body of knowledge. It's the 20% layered on top that is specific to the industry. So what I'm basically getting at is if you follow just the OWASP top 10, you would have covered 80% of security vulnerabilities. It's not perfect, but it's certainly better than the 0 that I came into my job with when I started coding. I want you to think a little bit about what you've built and then get your head out of it. The more you are in the code, the less you can see the big picture because you're just trying to solve a targeted problem. When you are focused entirely on the project, you are not paying attention to all the other places the insecurities are coming from. Where in that flow could that happen? It's great to do, it's a very bonding experience, by the way, as if you were in a larger company where different teams are responsible for different pieces of software engineering, to go ahead and do a vulnerability exercise of saying, where, if I was the hacker, where would it be easiest for me to get in? And then each of the teams can think about how open is that door? How secure is that door? Is the door just closed and not locked, or do we have a deadbolt on it? This was awesome to do with my newest team because I didn't think at all about how they implemented some of their internal systems. Often, when you're just using software applications inside of a company, there's the almighty firewall, that, hey, it's all safe because the firewall keeps everyone out. So once they're inside that firewall, everything should be open and available to the employees that work there. I can tell you that that's not enough. I ended up having about a week where I couldn't touch my computer because they not only got past the firewall, they were able to accurately do password resets on some of our internal work email accounts. So I couldn't even get into anything because they couldn't tell where the hacker was coming from because they changed their IP address every 30 seconds. So they had no way of knowing that I really was the user that should be allowed into my system. So you see, if everything were to start breaking down, you may not be able to help the other aspects of that stack or flow, but you can definitely lock down your room. And you should have a really formalized way of interacting with any sort of data that goes over the wire, any sort of call. And again, it will be especially difficult to tell an existing API team that I can't just call your API and trust it. You don't even you have no authentication in place. Sometimes basic authentication is not enough. Sometimes you need something more. And that's something to raise the flag about. If you're not sure if what you just coded is going to pass just the basic security test, have somebody you trust take a look. It can't just be you. Get another pair of eyes. One that you not only trust, but actively collaborate with. There are no stupid questions when security is at stake. I failed to grasp this in the beginning. I'm very shy about how much I feel I know. I have a terrible imposter syndrome, and it really prevented me from collaborating effectively. So the only way that I was able to get over it when I thought I saw something kind of smelled off, it looked a little strange, was to reach out to somebody I knew that was allowed to look at the code base and sign that NDA, that probably would know. If you don't have somebody that has a little bit of security knowledge in your team, there are companies that will come in and do these security audits for you. Maybe that's a suggestion you should bring up. Nobody really wants to hear that their code isn't secure, but do you really want to find out on the front page of the news? That's much more embarrassing, I promise you, than having a security auditor tell you that maybe you should adjust a couple things. Everyone has dealt with cross-site scripting errors, right? Most people do hacks to get around cores. Forget that they did that, and then build the rest of their project around that being the working environment. So when a hacker comes in that later exposes that vulnerability, and when you try to fix the core's vulnerability, suddenly your project is broken by design. You have to pay attention in the very beginning. The best way that I've thought about this is that if the first step was to create your repo before you start coding, the second step should be setting up all this other security stuff so you never have to think about it again. There should not be a step in your deployment where you slap security on after you build it. If you do it first, then you don't have to think about it. I like that. I like not having to worry about it later. If you secure it in the very beginning, you can confidently say, yes, all this is already in place. Now let's get to building. Brute force attacks can happen to your projects. Sometimes they cost you money, sometimes a lot of money. Hackers will often hold databases for ransom just by running a list of commonly used admin passwords. Still, we are still hearing about this. Admin is still the most common database user credential, and it's often not changed. I can tell you who's not doing that, the security professionals. Guess who's doing that? It's also often not stored in a password manager, so you don't have to think about it. You don't have to put it in a Google Doc that you share with the team openly on an insecure server. There are basics you can suggest to your network admin, DBA, and/or developer team handling deployment. I learned this one the hard way. You need to be transparent immediately. Sound the alarm right away once you discover a project has been hacked. Send it up the chain, and don't try to outsmart the hacker and be a hero. Because once that happens, you might have to get a legal team involved, all the way up to the owner of a company. Ask for help when something like this happens, and don't interface with the hackers yourself. I've gone through probably 17 breaches now. Some of them I was on the team that wrote the code. Some of them I was just on the security side. I can tell you nobody wants to build stuff that is going to be hacked. So let's act a little bit like we care about that and just do that stuff in the beginning. But please tell somebody right away when it does happen. If you do that, you're much less likely to get in trouble than if you just try to fix it because you noticed all of a sudden you've got huge amounts of calls coming through that are trying to crash your DNS. Just say something immediately that it's going on. Most companies don't expect you to be the expert in this stuff, but they would like you to consider the basics. I'm not going to ask you today because we don't have time for that, but I'd like you to consider in your own team, or maybe just your own projects if you're solo, what have you done in the past that was definitely not secure? Maybe it was one of the things I shared with you today. Maybe it's something else that I haven't even listed, because there's no way in 30, 40 minutes I could go over all the things I've learned, but these are probably the most important steps that I took to heart that shifted the way I coded. If you're interested in making sure you have that checklist, the next time you start a project, this is where this deck is going to be. And I'm interested in what else you would like to see spoken about more that you don't think is spoken about enough. You can always talk to me on Twitter. I'm Coraline, and thank you very much for listening.